Hello students, today we solve problems of larger polynomials. So far we were dividing and finding zeros of quadratic polynomials. Now we will find polynomials which are larger than the quadratic polynomial. Now in this case it is a polynomial with the highest degree of 4. Okay, that is a quadratic polynomial. Now how do we get the zeros? Now we are already given two of its zeros are square root of 5 upon 3 and minus square root of 5 upon 3. These are two of its zeros. Now since remember the number of zeros, how many zeros a polynomial has will be, you'll get an idea of how many zeros are there in a polynomial based on the highest degree of that particular polynomial. So in this case the highest degree is 4, that means there should be 4 zeros in total. 2 are given, we need to find out 2 more. So let us see in this video how do we find out the other 2 zeros. Okay, so we will put it down as since 2 zeros, since this is the sign for since, upside down of therefore. Since 2 zeros are square root of 5 upon 3 and square root of 5 upon 3, this is negative, and therefore we can say that x minus square root of 5 upon 3, okay, and x plus square root of 5 upon 3 are the factors of the polynomial. Okay, see how can we write it this way? If you just put it down as zeros, the x raised to 5 upon equal to 0, what do we get? When we take this square root 5 upon 3 on the side, we'll get x equal to square root of 5 upon 3, which is the same as this. Okay, so we are just going in the reverse direction now to find out the other 2 factors. Okay, so there's no need to show just now what I've shown. You can straight away write this. Okay, now we can say that x minus square root of 5 upon 3 into x plus square root of 5 upon 3. So obviously these are factors, so we can multiply them, and what do we get upon multiplication? Okay, so this comes in the a square minus b square form, so that will be equal to x, okay, x square minus square root of 5 upon 3 square, okay, a minus b into a plus b. Okay, so it is a minus b into a plus b form, and what do we get here? A square minus b square. So this is an identity. This is an identity. So just erase this. So what do we get here then? We will get x square minus 5 upon 3. X square minus 5 upon 3. Okay, which we can write it down as 3x square minus 5 upon 3. Okay, this is what we can write it down as 3x square minus 5. So I just took the LCM, okay, made sure that the denominator is common to both of them, and got the numerator. Now in this case, if you notice, okay, then this 3x square minus 5 becomes a factor of the given polynomial. So therefore we can say this implies that 3x square minus 5 is a factor of polynomial. Okay. Okay. In this case, now why do we say 3x square minus 5 is a factor of polynomial and why not 3? See, for any term to be a factor of the other one also should be a polynomial, and for a polynomial to be there you need a variable. Okay, so in this case we have two terms, one with a variable, so because it is a polynomial of x, now that is why 3x square minus 5 can be taken as a factor of the given polynomial. So we'll move forward and we'll use this 3x square minus 5 as g of x and divide it with the polynomial that was given. We'll see what it is. Okay, so we assume that g of x is equal to 3x square minus 5 and p of x equal to 3x. This is the original polynomial that was given. Of this we need to find the other two zeros, that is 3x raised to 4 plus 6x cube minus 2x square minus 10x and minus 5. We are now going to divide this 2 in order to find. How can we divide this? Because we have already said that this is already a factor of this, and remember from the previous video, for one polynomial to be a factor of another polynomial, the remainder has to come 0, so if we have already said that g of x is a factor of p of x, which means our remainder should come 0. So if we do not get our remainder as 0, that means something has gone wrong somewhere. Let us see if we can get our remainder as 0. So 3x square minus 5 divided by 3x raised to 4 plus 6x cube minus 2x square minus 10x minus 5. Highest power is 4, here it is 2. That means we need 2 more. Okay, we don't need to multiply it with 3 because 3 is already over here and we need 3 only over here. So 3x square into x square gives us 3x raised to 4. Minus 5 into x square will give us minus 5x square, which comes here. Let us change signs all across and this will get cancelled. Minus 2 plus 5 gives us plus 3x square. Let us bring this 6x cube down. 6x cube, and we put it down as plus over here. Now the highest power is 3 in the dividend, highest power in divisor is 2, which means we need one more. So and since 3 is in the divisor and 6 is in the dividend, we can divide and get as 2x. So 3x square into 2x will give us 6x cube. Minus 5 into plus 2x will give us, cancel this part out as well, we'll go back again. So minus 5 into plus 2x will give us minus 10x. Okay, now in this case the sign changes, this gets cancelled and we get 3x square around here, we'll bring minus 5 down. Now in case of this, the coefficient and the variable are the same, the power is the same, we just write plus 1 over here, so it will become 3x square. Minus 5 into plus 1 will give us minus 5. Let us change signs, this cancel, we get the remainder as 0. So just as I said that the remainder has to come 0. So now that the remainder has come 0, we can put this down as 3x raised to 4, it is copying down this polynomial, plus 6x cube minus 2x square minus 10x minus 5 can be written as equal to its factors. Which are its factors? First one was 3x square minus 5, and the other factor is this quotient. Okay, x square plus 2x plus 1. Okay, so now we have got factors. Using this factor, we have to find out, we'll get the other two zeros from this factor. Okay, so how do we get the other two zeros? We just split the middle term in this case. So I've taken the factor separately, the one which we just found out, x square plus 2x plus 1, which we can write it down as x plus 1 into x plus 1. This is nothing this is in the form a square plus 2ab plus b square. Okay, it is an identity. Which one? A plus b the whole square. Okay, it is in that form. So here it is x plus 1 the whole square. So which means we get the zeros from here, which is x plus 1 equal to 0, which is x equal to minus 1, which will be the same in both the cases. Okay, so therefore the other two zeros of the polynomial are minus 1 and minus 1. Okay, and then we'll just write down all the zeros of the polynomial. Therefore all the zeros of the given polynomial, write the of the given polynomial are square root 5 upon 3, which was given, minus square root 5 upon 3. Sorry, just erase this part. Minus square root 5 upon 3, comma, minus 1 and minus 1. In the next video, we will learn how to find g of x when p of x is given and the quotient and the remainder are also given. Okay, that is using the division algorithm. So, hope you found this video useful. Thank you.